is section 1.6. It's called the midpoint and the distance formula. So first thing we're going to do is we're going to talk about something called the coordinate plane. Coordinate plane has room for coordinates on it. That's why it's called the coordinate plane. So you've got an x-axis and a y-axis, and you've got points on there. So you can put points, and all your points are given as x something, comma, y something. So we'll call them x1 and y1. Then you could have a second point over here. Let's call it x2, comma, y2. And there's numbers there. So there's 2 numbers here, and there's 2 numbers here, which means you have how many numbers? 4 numbers. All right, you're going to take those 4 numbers, and you're going to plug them into what we call the midpoint formula. Okay, so midpoint just means in the middle. So if you have 2 points, you want to find the point that's exactly in the middle. So to do that, you're going to take the average of the 2 points. So you're going to add your x1 and your x2 and divide by 2. And then you're going to take your y1 and your y2, add them together, and divide by 2. Woo! Bless you.
Thank you.
So let's try it. Example number 1. I'm going to give you 2 points. The first point is at P, which we're going to put at -8, 3. Then we're going to do another point Q. It's going to be at -2, 7.
Slow down. Slow down.
Yeah. Okay, just hold on to it. I'll grab it in a minute. Okay, so here's your 2 points. You've got your first point P and your second point Q. This is your x1 and your y1. This is your x2 and your y2. So we're going to take those 4 numbers, put them in this formula, and it's going to tell us what the midpoint or the point in the middle of those 2 points is going to be. And here's what it looks like. We're going to put it in the parentheses, just like that. We're going to take the x1 and the x2, add them together. So we're going to have -8 plus -2, and we're going to divide by 2. Then to get the y coordinate, we have to add the 2 y's together. So we're going to say 3 plus 7, and then divide by 2. From here, all you have to do is simplify. So as long as you plug it in correctly, it's just like basically calculator work from here. Okay, so if you have a calculator, you can add the -8 plus the -2. You should get -10. Then you can add 3 plus 7, which is +10. And then the last step, you just do -10 divided by 2, which is -5. +10 divided by 2, which is +5. So the midpoint, or the point in the middle of those 2 points, is at -5, +5. Okay. And that's how you use the midpoint formula. So in the title, there's also the distance formula. Distance formula is going to tell you the length, how long something is. What's the distance between the 2 points? What is its length? Okay? Distance formula is this big, long square root thingy. So you're going to have a D equal, let me make that just a tad bigger, to all of this square root stuff. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And just like the midpoint formula, you have 4 spots to plug in. 1, 2, 3, 4. Those 4 spots is where you're going to plug the 4 numbers from the 2 points that I'm about to give you. Okay? So this is example number 2. Okay. So for example number 2, we're going to use point D, which is at 3, 4. And we're going to use point E, which is at -2, -5. Bless you. So 3, 4 is your x1 and your y1. And -2, -5 is your x2 and your y2. The first couple times you do these problems, I highly recommend writing the x1 and the y1, writing the x2 and the y2. That way you make sure you get them plugged into the correct spot, especially with this distance formula because it involves subtraction. With subtraction, order matters, right? With addition, order doesn't matter as much. Well, you need to get the x's together on the midpoint formula, but practice getting it in the right spot. Then after you've done 5 or 10 of them and you're comfortable with it, you probably don't need to label them anymore, okay? So let's plug in under this distance formula, under this big long radical, our numbers. So we want the x2 minus the x1. So -2 minus 3. And then we're going to square that. Plus the y2 minus the y1. So -5 minus 4. And then square that. Okay? From here, you want to simplify and think about for a second what we call order of operations. What needs to happen first, right? So you've got PEMDAS, or please excuse my dear Aunt Sally if you've ever heard of that, right? Yeah. So you want to do parentheses first, then exponents, then if there's any multiplication and division, do those 2 in the same pass. Then if there's any addition and subtraction, you do those last if there's any left, okay? So let's do parentheses first. So leave the square root alone. Inside this first set of parentheses, we have -2 minus 3 more. Where does that end up? -5. Okay? In the second set of parentheses, we have -5 minus 4 more. -9. Okay? Now we want to do our exponents. So still under the radical, we have -5 squared. So -5 times -5 is 25. And then -9 squared is -9 times -9, which is 81. All right. We have some addition under the radical. So we want to add 25 plus 81. I got 106. Good. Okay. So when you have a radical, you can look back in our little flip book where we talked about how to simplify radicals. And you want to see if there are any perfect square factors of 106. So let's get its prime factorization, right? It's even, so we know 2 goes in there. And 2 goes in there 53 times. But 53 is prime. So are there any perfect square factors? No, that means the simplified radical is the square root of 106. Can't simplify it anymore. The other way it may ask you to give your answer is as a decimal. So if you have a calculator, oops, you can, let me move it over just a tad for a second so I can show you on the calculator. On the calculator, you're going to use that little blue square root button, so you have to hit the second button first. but make sure it displays, can we see it? There it is. Make sure it displays the square root on there. Type 106. And in front of the decimal, you write down everything. So 10 point. And we're going to put the wavy equal sign out front. And then after the decimal, we have a 2/10. Is it going to stay 2 or round up to 3? 3. Okay. Finish copying that down, and then let's look at your worksheet from yesterday. We're going to just flip it over. Bless you. Okay, so yesterday we did the side that said 1-5. Flip it over to the back. We've got the side that says 1-6. So over the top, bless you. Print your name. Today is the 7th. Period 3. All right, first 2 questions are some fill in the blanks, okay? Then jump down to numbers 3 through 5. It says the midpoint of a segment has an x coordinate that is the average of the x coordinates. You add the 2 x's together, divide by 2. The midpoint of a segment has a y coordinate that is the average of the y coordinates. Add the 2 y coordinates together, divide by 2. So number 3 says Q has the coordinates 0, 0, and R has the coordinates 3, 0. Find the midpoint of QR. This is like example number 1, but it's even easier because one of the points is 0, 0. It's almost too easy. Okay? Then they're going to change the endpoints on you. Now they're going to give you S, and they want you to find QS. So you have to use Q from this one. This one's Q. This one's R, this one's S, this one ends up being T, okay? Q, R, S, and T. So just pay attention to which points they want you to use, but all of them are midpoint. Okay, so if they say Q and S, you got to use Q and S. If they say Q and T, you got to use Q and T. All right? Exercises 6 and 7. I is the midpoint of HJ. H has the coordinates 0, 0. You should plot that on the coordinate plane that's right there. And I has the coordinates -1, 2. You should plot that as well. Sketch these points in the coordinate plane. Study the graph and guess where J will be. Okay. So some of you might have different answers, but hopefully you're a good guesser and you can figure out just by looking at the coordinate plane where the midpoint's going to be. Then find the coordinates of J using the midpoint formula and see if you are correct. Okay? You might be. Some of you can figure it out just by looking at it. Okay. So numbers 8 through 12. Manuel is out for a jog. The thick lines on the grid are jogging paths. He is on his way home and is at D. So D's right there. His home is at E. Each unit on the grid is 1 mile. Name the coordinates of D. That's going to be something, comma, something. Where's D located? Okay. Find how many miles Manuel will jog if he goes straight to the x-axis. Okay. Find how many miles Manuel will jog if he stays on the jogging path all the way home. So you're going to count with your finger or your pencil. You're going to count with your finger or your pencil. And then number 11, find how many miles Manuel will jog if he goes straight to the y-axis. So you're going to count. Okay. All right, so you're going to work on that worksheet. Most of you will finish it, and then you can start the problem solving. So let's look at the problem solving. Problem